In this video, we're going to talk about improper intervals, and we're going to answer the question of how to tell when an integral is improper or not. So there are two ways we can determine this. We can determine if an integral is improper if the interval of integration is infinite, or if the integrand is discontinuous in the interval. So let's take a look at our example problem we have down here. This example asks, what is the interval, or the integral from 1 to infinity of x squared plus 5 to the dx? So how do we determine if this integral is improper? Number one asks, the interval of integration is infinite, then it is improper. So we have an infinity sign right here, so therefore it is improper. It's as simple as that. There's no need to overcomplicate it. And we can say the same if we have, let's say, an infinity down here going to a number. So the integral of negative infinity of 5 has the infinity, so therefore it is also improper. We can say the same if we have it going from a negative infinity to infinity. So if there is an infinite number on either the bottom or the top of our interval, it is improper. So what if we don't have an infinite on either of these? So let's take it from the interval of 1 to 5 to this function. And to solve this, we'd need to use our second example, which is the integrand is discontinuous in the interval. So what this is saying is, well, first let's determine what the integrand is. Our integrand is, let's go purple. The integrand is going to be our function. So in every integral problem, we're going to have the integral sign, our function, and then a dx. So we need to determine if this is discontinuous. So an example for that, let's look at this graph over here. So we're looking for the integral of 1 to 6 some function dx. And we have a point that's discontinuous at x equals 5. So when we're looking at an example like this, we're only concerned with the numbers from 1 to 6. So anything to the left or to the right of that, we don't care about at all. We're just worried about the values within our interval. So we have a point of discontinuity within the interval, so therefore it would be improper. Now let's look at another example on Desmos. Let's look at 1 over x minus 2. So when we look at this, there is a clear point of discontinuity on x equals 2. Now, a way we can check our work for this is if we take the interval of, let's say, 0 to 4 of 1 over x minus 2 dx. Now this isn't going to show us anything in here, I just wanted to write it down so you can see what we're looking for. So from the integral of 0 to 4. So with this we're just looking at our x coordinate. So from 0 to 4, is there a point of discontinuity? Well, yes, we have a point of discontinuity at x equals 2. So from 0 to 4, our function is or our integral is improper. Now, if you remember what I said on our last example, the only way this function would not be improper is if we're dealing with numbers that aren't within this discontinuity. So an example would be, let's say, from 0 to 1. 0 to 1, there is no point of discontinuity, so it is not an improper function. Same goes for if we look at the right side. Let's say the integral of 3 to 6. There is no discontinuity, so therefore it is not an improper function, or an improper integral. Okay, let's go back to here. So that's pretty much all I wanted to cover in this video. Just some key points to take away from this is if there is an infinity. Here, let's erase this real quick. If there is an infinity in our interval, it's always going to be improper. No matter whether it's from a negative infinity to a number, or a number to infinity, or they're both infinite, it's always going to be improper. And then our second one, if there is a discontinuity within our interval, it's also going to be improper. So if we're taking, let's go back to our integral of 1 to 5, if we have a discontinuity at any number in between 1 and 5, it's also going to be improper. And those are the main points I want you to take away from this video.